Well, hi, good morning. Thanks so much for joining me again in my shop here, where I'm working on trying to determine the operating factors, I guess we could say, or set up some equipment so I can measure the operating factors for this particular tube, in the hopes that I can understand how this tube operates in great detail, this particular one, and then put this particular one into a tube tester. And then I'm going to know something about how the tube tester is responding to a known tube. That's the theory. Am I going to get there? Well, I only have about 50% faith that I'm going to actually get through this process with some successful result that will make me feel more certain about this tube, or any tube that I do this with. So I don't have complete faith in myself here, but that's okay. So one step at a time. If I can get one step done, I think that's pretty good. So the first step, which I succeed in doing, is just getting the right voltages onto the right pins and just getting the tube to conduct and the like. What I've done since then is since yesterday evening, I was in here adding some more monitoring equipment. So I have an ammeter now that's going to measure the current flow into the heater of the tube, just so we become aware of it. And I've got a voltmeter connected here. This voltmeter is going to read the plate voltage with some accuracy on it, because ultimately if I'm going to try to measure the GM on this tube, my first attempt would be maybe later today, later in this session, to do it using a static setup. So instead of having an oscillating signal going to the grid and then an oscillating result and then figuring out the GM from there, I'm going to use steady state voltages. I'm going to adjust the grid voltage, probably 1 volt, measure the difference in the plate current, and that should allow me to determine the GM. If I can get through one of those today, or just one process, that'd be great. Is it really accurate and true? Gee, I don't know at this point, but let's just see if I can get that far. That's my objective here. I've got my decade resistance box out. The purpose of this is ultimately to become the load resistor for the tube in the plate circuit. But apparently at this point, from what I've read and what I understand, I don't need a resistor in the plate circuit to do the GM test. It's not really required, since I can measure the plate current. Plate current being in this meter, not this one. Plate voltage, plate current. Now, I haven't had this meter hooked up and operating here. Whoops, am I standing in front of it? Let me move my camera here. Right. Giving you a long shot so you can kind of get a bigger perspective on what's happening on my bench here, since there's quite a bit of equipment involved now. Good show. We'll probably use this for making spot measurements and verifying things and whatnot. Okay, put this guy on. The expected current flow in the heater is, I think, 150 milliamps. Turn this on. I'm turning on my power supply above here. On standby, now that should turn on the heater here. We should start heating up, which means we should see a current flow in here. But, oh, I'm still on standby. Well, no, standby was supposed to heat it up. Okay, so something's gone wrong already. We're off to a bad start here. Just looking everything over quietly. It'll take a while to feel actual heat building up in the tube here. Milliamps. Common milliamp. It's a 400 milliamp fuse in this line. Could I have possibly popped that? I can't imagine. Well, we're off to a bad start. Let's just double check things here. Whoops, this just fell right out. Is that the problem? Nope. Did I misinterpret what on meant? I flip this on and see if this comes up. No. No, I'm pretty sure I discovered that with this on standby, with the switch on standby here, the heat still goes. Okay, I said something about using this other meter to poke around. Let's start poking around. Is there any heater voltage? I'm really at a loss. Start right back to square one here. So this should read the AC voltage on this meter, as long as I don't get in front of it here. That's reading, this is the 5-volt scale. There. Okay, so we're just picking up a little noise there at first. So on the 5-volt scale, this is showing 2.5 volts. That's suggesting there's a short circuit on this. Come on. What's happening? Okay, we're really back to square one. Resistor off here. That's probably why I got a bad reading. Okay, so 6.3 volts. We'll probably see 6.3 now. 6.3 volts. And the voltage is there. Put this back on the ground. Put on this other negative lead here. That's for the meters. Now, well, why is there no current flowing in here? What in heaven's name am I doing wrong? I'll put this into the 10 amp setting. Maybe this didn't make contact. Maybe the plug doesn't work. Okay, wait a second. I got something plugged wrong here. Okay, hang on. This might be the fix here. Yeah. Okay, so I don't know what I was doing there. What was I doing? I don't know. Whatever I was doing, I'm doing the right thing now. Wait a minute. Where did it come and went? Where'd it go? It should be 150, or should say 15 here. See, so we're in the milliamp scale, but plugged into the 10 amp thing. So I think that might be a problem. Pull this out. Stick it here. Nothing again. Damn, what's happening here? Just a sec. There's something stupid about this meter that I'm not getting. You know what? It shows DC up here. saw it. AC. Oh, jeez. Oh, man. I should learn to use my instruments. So down here it shows DC and AC, and I figure, well, it must be automatic. Apparently it's not. 0.6 amps flowing into here. Does that sound right? 0.6 amps. It sounds crazy high to me. Heater current, 0.7 amps. If 0.7 amps if you've got 6.3 volts down there. That's the good question. Let's measure it now very accurately. We'll do this more accurately. On this meter. Yeah, accurately on that meter. Switch to AC. No resistor in the good. So this is the heater voltage now. The voltage arriving here. According to this meter, it's 5.4 instead of 6.3. And I can make a voltage drop comparison by just measuring the same voltage but up at the supply and see if it comes out the same or higher. Then we'll know my wiring is insufficient to do this. So here it's higher. It's at 5.8 on this meter. And now what if I actually disconnect the power? And we'll see what this thing is open circuit. So keeping an eye on this meter. If I don't get in the way of it, I'm just going to break the current flow. Whoa! That was interesting. Now it's almost exactly 6.3 or somewhere certainly in the range. But you can see how much of a voltage drop is being pulled. So at least one of you commented on this problem. And it's very real, isn't it? 5.7. And we know the current is low. This is the main measurement here. I cannot vary the current the way I'm doing this. It is what it is. You don't have a line adjust or something that can compensate for this voltage drop. It's not even the right voltage right at the terminals. So I can continue with it like this, and knowing this fact now, because I'm still experimenting. I'm not actually making end game measurements here. I'm still just experimenting. So why don't we do that? An alternative I have to solve this problem, a good alternative I think, is to heat this up using DC from a controlled variable DC source that measures accurately both the current and the voltage. So I think ultimately that's where I'm going to get to with this. But for now, we'll leave it as it is. And next stage is putting voltage on the plate and then looking at the current flow in here. Yeah, we'll see if that actually works. Okay, I think we're ready to do that. Why not? Okay, plate voltage is going to show up here. Let's remember this now. So the plate voltage we're shooting for ultimately was 250, I think. So I'm on the 150 scale. So for now, we're going to bring it up to 150 to start with. And we're expecting at 250, oh, a C minus 16 volts. I haven't got a C minus meter on here. Do I? I do not have a C minus meter right now. So, but I did set it. It's still set the way it was. So we can also make a momentary measurement here. Let's do that just to be sure. This is on the 15 volt scale now. It should go full scale when I hit the grid. Grid. Let's take it off up here first. That didn't work very well. Oh, DC. Try it again. Not much of anything. Let's pick it off the tube here. So, oh, I know what's wrong. This was connected to the heater, and the heater is just an isolated winding in a transformer somewhere on the planet as far as this is concerned. So this has to be on the cathode. Cathode's pin 8. Pin 8 is here. Cathode is pin 8. Cathode is pin 8. Now I should be able to read this C- voltage here properly. There's nothing showing. What's going on here? We're on DC minus 15 volt scale. Oh, I know what's going on. I haven't turned the supply on yet. Okay, let's take it off standby. No B plus. All C minus should be there now. Now we'll see if we can measure. Okay, learning a little more about my equipment. Make a more accurate measurement here to see what it really is. So we're on the 50 scale. One here is 22. Didn't I measure it with another meter? 22. 22 was to drive the current through here. If I remember right. Do I remember right? I don't know. Okay. Let's raise the B plus, make some current flow in this tube. 34 milliamps was what it said in the manual. It's the normal quiescent current of this tube. Okay. There we go. So we're watching now B plus and current flow. And this is current flow of both the plate and the screen. The screen being about 20% of the current, something like that. Okay, we're heading up to 150. Going up, watching the current meter. Why is there no current? No current because there's no voltage. There's also no current on the supply meter itself. So something is amiss. Current flowing into the heater, no doubt about that. We have voltage appearing on this pin because it's being measured on this meter. Voltage here should be about 100 volts here. There it is. We have 100 volts on the plate. Now, according to two different current meters, there's no plate current flowing. No plate current flowing because maybe the tube's in cutoff because I've got the grid bias so high. That doesn't make sense. It's more likely I'm just not using this meter properly again. So I have it in the AC, DC, milliamp, amps. This says amps. Where's the milliamps? AC milliamps. What's going on with this meter? Oh. Okay, well everything should be fine. So it's got a setting here 20. That would be the 20 hole there to plug it in. The rest of them are milliamps. And the milliamp. The voltage is getting through. Why is the current not showing? Once again, what am I doing shooting this stuff on video? A lot of you appreciate me showing all my stupidity. I think I know why. I'm definitely showing you lots of stupidity here. Okay, let's do something stupid. I'll interrupt the supply here to the plate. You saw the voltage drop right there. I don't need to do any more. That's stupid. I'm measuring the voltage right at the plate. So I think, I don't know what to think here. Okay, C minus cutoff, the cutoff deal. Let's try that. I'll just lower it here. So we're seeing if this will trigger current. Lowering, it's dangerous to say lowering. I'm going to make the grid more positive. Less negative, I should say that. Less negative. Look at that. It was in cutoff. Well, another lesson learned. I'm supposed to have 35 amps here. Did I monkey with this control? Why is it so different today from yesterday? What? Okay, so let's just take stock of the situation now. We've got about 100 volts on the plate. We've got about 8 milliamps flowing in the plate circuit. And slightly low current in the heater. And, the problem here is I'm not measuring accurately B plus voltage, so we need to do that. I need another meter. Okay, let me go get some more meters. Okay, another meter. Not going to stand very well here, but I'm going to put in there. So this guy is going to measure the voltage on the grid. The grid is pin number 5. Pin number 5. Attach it to the cathode. And now number 5 would be 1, 2, 3, 4, 5 is tucked back here. Where did my pliers go? Lost my pliers. Okay, we'll try it with these. I don't think this is going to work too well. Let's see. There we go. Okay, so this guy's measuring, there he is, -8. -8 is giving us an 8. This is because the plate voltage is so low. That's probably what's going on here. So if we look at the, let's raise this whole thing up to the standard. Not the standard. Who's beeping? If I turn this off, does it break the current? Who knows? I got all these meters ready to go to sleep on me here. B plus voltage, 250, -16 on the grid. Okay, so we're going to watch this current. Don't let it go over 30. We're going to raise the voltage. The voltage is only 100 right now, so it's really quite low. So the 250 is straight up on this meter. Raising and watching the current. The current is shooting up. Okay, so what we're going to do is raise the C minus up to the -16 range. I'm watching this meter over here now. Get it up to the minus. Well, if I had to do this for every tube, wouldn't this drive you nuts? Okay, we're a little over -16. The current is down to 6 milliamps. Let's keep jacking up the voltage here. Up. Okay, we're in the 30 range now, and the voltage is around 200, somewhere in that range. Around the 500, make sure it's correct. We're at around 200 volts on the plate, 30 milliamps flowing, -16 on the grid. Heater is... What happened? Okay, think about this. I flipped this off. Oh, I know what happened. This has got to go back here. I'm changing the scales here. This is really Any clue what I'm doing right now? Select. How about that one? There's the one I need to push. Oh, what a dummy. I'm trying to build a tube tester. I don't know how to work a multimeter. Okay. So the next thing to do to try to get this thing right on target, because it's not yet. Wait a minute, is it not on target? Let's just see. Does it match? Not so much on target. Is it matching what it says in here? Let's try this again. 250 exactly. 16 and a half. Let's go 16 and a half. Okay. 16 and a half. Get down to 28. This should yield a 34 milliamp plate current at 250 volts. That should be low because the heater is low. So it should come out low. So we're watching this to hit 34 when this hits 250. 250 not far away. 250. 250 yields 50 milliamps. Okay, let's go take it back down. Take it back down. If we were using a glass tube, we might see the plate glow in here or something. Ooh, it's a hot one. Okay, so that's not adding up exactly the way it should, according to the book. Now, what is actually happening? This is not a brand new tube. There's no reason to think this is operating normally. There's really no reason to think that, other than the fact that I tested it in commercial testers and it was kind of okay. So what could be wrong with this? So low heater means low current, but we're reading high current here. How do you get a higher than expected current from a tube like this? Because the circumstances under which I'm testing it are not actually the same as in the book here. There's something more to this. For instance, this is talking about load resistance. I don't know. I don't know that I'm doing anything that would not be the right thing to do. Living my whole life in that state. Well, let's try making the GM measurement at this point. At the very least, it's a practice for what is coming. Something's definitely getting hot in my shop, though. Could even be this supply up here. Just make sure the ventilation isn't blocked on it. No, it's nothing much up there. Okay, I don't know what I'm smelling exactly. So here we go. We're going to take two sets of measurements under two conditions. First condition. Okay, we're going to do this at 200. We'll do this at 200 volts on here. The name of the game is holding this voltage steady. I don't know if holding it precise is really critical. Okay, so we're on 200. 200 is yielding a sleeping meter under 30. So we go. So 200 is what we're going to hold it at. 200 volts plate. The grid, we're at 16.5. Minus 16.5, and that yields a plate current. This is actually easier to do than I expected. 27.7. 27.7 milliamps. Now I can either raise the negativity of the grid or lower it and take a different current reading. I'm going to raise it because I don't want to put more current through the tube. So we're going to raise it. What should we raise it? We should raise it 1 volt. Yeah, in 16, I think 1 volt makes sense. These tests are generally done with a 1 volt change on the grid. Here we go. In doing it in a laboratory, so we want to go to 17.5. So this is actually how GM can be measured, supposedly. I shouldn't say that. I don't really know what I'm doing. So here we go. 17.5. Now the current is 25. So we go 17.5, and the current is 25.4. So 27.7, 25.4. So GM is it's the change in grid over the resulting change. I'll run out on me. You know what? It doesn't matter what it is. There's always something coming at me in this shop. I have to compensate for all the time. Yeah, let's use a pencil. Over the change in the current in milliamps. So that's easy. That's 1 volt over the change, which is 2.3 milliamps. Take that out, put a K there. 1/2 K. 500. GM equals 500. Is that right? 1/2 of K. So this comes out somewhere around 500. But in the tester, it measured 2,000, and I believe it measured 1,500 in this one. And the GM is supposed to be 2,500. So am I to now to say, oh, this is a 500 tube, we'll use that from now on? No. I am to say nothing and continue on. I got that result. I did that at 200. What if I do it again at 250? I just don't want this to go over 30 milliamps. Let's try it again at a little higher voltage. We'll take it up to 250 here. Watching that current flow. Okay, what we'll do is we'll knock this down with grid voltage. Okay, so down around 25 milliamps. Is there a grid voltage range? Is that such a thing for a tube? I don't think so. I think if you just put too much negative on it, you shut the tube down. I don't think. I'm not going to find anything here. What am I even looking for? Don't even look. So minus 23 is yielding 25. Let's write these down again. So minus 23 yields 25.3 milliamps. Make this 24.2. I had it. There we are. Right on the money. Almost. 24.2, 22.9. 22.9. Make the same calculation again. It's 1,000 over the change. So, oh, yeah, these are hard numbers. You can't even see them on my sheet here, but it's just as well. Yeah, a little bit of just tough arithmetic here. So carry the 1, 4. Ooh, just a 1.4. So in this case, it's 1.5 of 1K. So 1K divided by 1.5. I don't know, what's that, 700? 700 this time. Something like that, roughly. Okay, let's calm this guy down. Down on the B plus. Down on the C minus a little bit. Let's keep it up there. So really, I think the next thing I should attempt here is to do a dynamic measurement of GM. And the way that's done is by applying a signal to the grid and then observing the variation on the plate. You actually run the tube with a signal. That's going to take a little bit of thought before I do that. I have interests in protecting my equipment while I'm doing this. And make a silly mistake and just damage a piece of equipment that I very much value. that's not so good. So I'm going to think about what I've done today so far, as usual, during the day, and come up with some more ideas for how to advance this one more step. One more step being a dynamic measurement of the GM in this tube. So far I've got 2,000, 1,500, 700, and 500. That's a pretty good range. So thanks a lot for watching, and I'll see you on the next video. You'll see me.